Hello, algebra students. It's chapter 4, section 4. Pause the video if you haven't already attempted the review problems. I'm going to work those, but I want you to work them first and then use the video to check your work. So stop the video. Okay, so hopefully you were able to master point slope and slope intercept, converting back and forth from one equation to the other. In today's lesson, we're going to talk about parallel lines. Parallel lines have the same slope. They're going to rise and run and rise and run and rise and run and rise and run at the exact same rate. Oh, that looks like a little chevron print. Well, those lines that are rising and running at the same rate are going to be parallel. We're also going to be talking about perpendicular lines. Oops, I don't need to write the word lines. I already have lines there. Okay, so perpendicular lines do not have the same slope, obviously. Instead, they have opposite reciprocal slope. So here's a better drawing than I had of parallel lines. We have Mr. Potato Head telling us that parallel lines have the same slopes. Remember that parallel lines will never intersect. That's the definition of parallel lines. They're coplanar lines in the same plane and never intersect. Perpendicular lines, by definition, form right angles. So please realize that whenever we use the word perpendicular, we mean that we know there's a 90-degree angle in the corner of the two lines. And again, they have opposite reciprocal slopes. So opposite reciprocals, if I give you A over B, the opposite of A over B is negative A over B. So opposite takes care of the sign. The reciprocal of A over B is B over A. So you're not only taking the opposite, you're also taking the reciprocal. So be careful when they're perpendicular. Okay, and here's a little summary of everything that I've just said. All right, so let's look at an example. Write and graph the slope-intercept form of an equation for the line that passes through this point and is parallel to this given line. Okay, so if it's parallel, our new line that passes through this point also has a slope the same as the line that it's parallel to. So for our line, our slope is going to be the same, 1/2. So we want which form? Slope-intercept form. So for just a minute, I'm going to temporarily use this x and this y and plug into slope-intercept, which is y equals mx plus b, but I'm going to use y is -2, m is 1/2, x is 4, and I need to find b. So 1/2 of 4 is 2, and now I'm going to subtract 2 from both sides, and b is -4. So I subtracted 2 from both sides. So my new line is y equals 1/2 x minus 4. Okay, I'm going to let you practice number 2, the exact same type of problem. Then we're going to talk about perpendicular lines. So you can pause now and do number 2, or you can come back to number 2. I'll be checking to see that you attempted those. If a line is perpendicular to a line in this equation, what is its slope? Okay, so I need to give the opposite, which means instead of being positive 1/2, it's going to be negative. Well, if my pen will write, it's going to be negative. So I need negative, and I need reciprocal of 1/2, which would be 2 over 1. So the slope of a line perpendicular to a line whose slope is 1/2 is -2. If the line is perpendicular to this equation, what is the slope? Well, guess what? It's the same slope, -2. It does not matter that we have different y-intercepts. What matters is that we're looking at slope and we do opposite reciprocal. All right, so our first real perpendicular problem is actually a geometry problem, and I've taken the time to go ahead and get my bearings on the graph. It took me just a second. 0 is our origin. So that means a lot of what's happening, the points here are in the third quadrant. If you remember quadrants, it goes first quadrant, second quadrant, third quadrant, and fourth quadrant. So I have 1, 2, 3, 4 of the 6 points are in the third quadrant. So that's why they're all negative. Negative 5, negative 3, negative 4, negative 10, negative, negative in the third quadrant. So let's read the problem now that we know our points that we're working with. It says the height of a trapezoid by definition means that you have two sides that are parallel and two sides that are not parallel. So you always know you have parallel sides if they're giving us a trapezoid. And it says the height is the length of a segment that is perpendicular to both bases. So in my little rough sketch here, if I told you these were right angles, then this would be the height of the trapezoid. The picture they've provided us, obviously these are not right angles. So let's keep reading. The question is, in trapezoid ARTP, they name it by its vertices, the points at each corner. RT and AP are the bases. If they're the bases, then those are the parallel sides. So this side is parallel to that side. AP and RT. Can EZ, here's the line in question, be used to measure the height? Well, if EZ is the height, this needs to be a right angle, and we do not know. It did not tell us it's a right angle, so that's the question. Is it or is it not a right angle? So we need to find their slopes to determine if they are perpendicular. So I'm just going to pick one of the bases. So I'm going to find the slope of AP. Find the slope of AP, and I'm going to be using -4, -10, and 6, 0. So -10 minus 0 over -4 minus 6 gives me a slope of -10 over -10, which gives me a slope of +1. So that's the slope of AP. Now let's find the slope of EZ. And if it's the opposite reciprocal, which by the way, the opposite reciprocal of 1 will just be -1. So for EZ, I'm going to be using -3, -1, and -2, -8. So I'm going to say -8 minus a -1 makes +1 over -2 minus a -3, which makes +3. So that gives me -7 over 1. Well, the fact that there's a 7 in the problem tells me that they're not opposite reciprocals, so no, not perpendicular. If they're not perpendicular, then is EZ the height? The answer is no, not the height, because they're not perpendicular. Are the bases parallel? Well, you're going to learn in geometry that if I tell you it's a trapezoid, then by definition you're going to know that the bases are parallel. But what I want you to do here is to check our math. Don't take my word for it, but see if they have the same slope. Okay, so just to show you that it'll work, we're going to use our points for TR to find the slope of TR or RT. And I apologize that my screen keeps. So TR, we have -3 minus 1 over -5 minus a -1, which becomes plus. So that's -4 over -4, which equals, and I don't know why everything's jumping around, equals a +1. And we already found the slope of AP up above here, and it was 1. So yes, they're parallel because they have the same slope. Okay, so another geometry type problem I want you to look at and see if you can determine if JL and MK, if they're perpendicular or not. I need to fill this in on your notes. Is JL perpendicular to KM? That's the question. If they're perpendicular, then they are diagonals. So check for perpendicularness. So while I'm scrolling to the next page, why didn't the skeleton cross the road? He didn't have any guts. Okay, on the back, determine whether the graphs of y equals negative 2x plus 1 and x minus 2y equals negative 4 and y equals 3, determine whether they are parallel or perpendicular. Well, you would think you would know by looking at them that none of them are parallel. So that's obvious. But now to determine if they are perpendicular, the only two that look like they might be in question is the blue line where slope is negative 2 of our blue line. Maybe I should have written that in blue, but here it is. The blue line slope is negative 2 and the red line slope is, what is the red line slope? Let's solve it. We'll have to take x minus 2y equals negative 4 and solve for y. So negative 2y equals negative x minus 4. Divide by negative 2, and negative over negative makes positive. So this line's slope-intercept form is going to be 1/2 x minus 2. And so the red line slope is 1/2, and that is opposite reciprocals. So yes, they are perpendicular. Or excuse me, at least one set is perpendicular. Now, I told you by looking at the graph we could tell that none were parallel. In this first example, it was obvious. Now, in the second example, again, I've written here, do not assume. We are not supposed to make any assumptions. So, because it's on a graph, on graph paper, it's pretty easy to see, but a lot of times there will not be a picture provided. So let's go ahead. The red line is 1/3 x plus 2, and let's check into the green line. It's the only one that could possibly work. And so I'm going to take 2x minus 6y equals negative 5 and put that in slope-intercept form because that's the quickest way to find the slope. Divide by negative 6, and the green line makes y equals, negative 1/3. Or no, it was a negative 6. It keeps erasing. So negative over negative is positive 1/3. With negative 5 over negative 6, if I did my work correctly. So you have plus 5 over 6. And do they have the same slope? They do. So yes, these two lines, y equals 1/3 x, the red line and the green line are parallel. For the sake of time, I would like to ask you to try the last two. Pause the video and then come back and check. I will put my work on the screen. So pause now. Okay, so here's my work. I took the equation they gave me, and in green I worked it out to slope-intercept form, and here was its slope. So if I'm looking for a line perpendicular to that line, so from here I went to talk about the new line slope would be the opposite reciprocal, so negative 2/7, and it passes through this point. So I temporarily used the point for negative 1. Plug that in for y and for x, and using my new slope, negative 2/7, I can find b. So doing some math here, my y-intercept is 1/7. So my new and final answer is y equals negative 2/7 x plus 1/7. And that's the equation of a line perpendicular to this given line. So notice it's opposite reciprocal. Okay, I'm going to leave you with number 2. Have a great day.